Alright, so we got through some of the tough stuff, and now we're going to get to the easy stuff. Domains of functions. Okay, well, anytime you talk about a function, your domain is your x values, and when you're talking about your x values, you basically say all real numbers unless there's some sort of restriction. So if you have what we call, if you say it's all real numbers, that's what we call an implied domain. So that is your set of all real numbers for which your expression is defined. Well, it's implied that your domain is always going to be all real numbers. We know that's not true because sometimes we have limits. So we need to go through a few examples. So here for 5, we're going to find the domain of g of x is 4 over 9 minus x squared. Well, we're going to say our domain is all real numbers. However, we have a problem. Your domain is all real numbers, but if you have all real numbers, that includes anything that could make your denominator equal 0. So you have to remember, if you have a fraction, your denominator cannot be equal to 0. So whatever x value to make this equal to 0, you can't have. So in order to solve this, what we're going to do is we're just going to take 9 minus x squared and set it not equal to 0. So if we solve this, this is a difference of squares. Your 3 is first. So it is not x minus 3, not x plus 3. It is 3 plus x, 3 minus x. If you would flip those around, you'd have x plus 3 and x minus 3. A positive 3 and negative 3 would make you have a negative 9. And that is not what you have. No, no, no. So what we're going to do is if you set each of these equal to 0, you would find out that x cannot be equal to 3 or negative 3. So then finally, when you write your domain, what you would say for your domain would be all real numbers, which you can abbreviate with a double stick R, except x cannot be equal to plus or minus 3. So that is how you would state your domain if you have a fraction. Now, if you don't have a fraction, say maybe you have a radical, we know that anything underneath a radical, in this case an x plus 2, has to be positive. So we know that we call this the radicand. So the radicand, that's what's underneath your radical. Your radicand for a square root has to be greater than or equal to 0. So we're going to take your x plus 2 and just set that greater than or equal to 0. And if you subtract on both sides, you get x is greater than or equal to negative 2. So to write your domain, oh gosh, you might see it written something kind of squirrely like, this is called set builder notation, where you have x. This means all x such that x is greater than or equal to negative 2. So I would accept that answer. You could just say, I really prefer this, x is greater than or equal to negative 2. Or you could put it in interval notation, which would mean you're starting at negative 2, and you can go all the way up to infinity, but you have to put a parenthesis around positive infinity, and you have to put a bracket around negative 2. So those would be your actual values. Okay, I'm glad that popped up. So there would be your domain. Now, think about what would be your domain if maybe you combine both of these and put a radical in your denominator. Would be a great question to ask someday.